Hello everyone, we are on video 2 today, and we are going to take a look at what is known as a leading term test. Okay, leading term test, we're going to look at, or it's going to be based on, the degree of your polynomial and the leading coefficient. Okay, so the general idea is if you have a polynomial, okay, whatever the leading term is, and that leading coefficient should give us a general idea of what your polynomial is going to be. Okay, in other words, if we look at the two ends, so the end behavior, and then there's some wiggling going on in between, okay, that end behavior can be determined by this leading term test. So in other words, if we know something's going up here or going up here, so both to infinity, and a lot of shenanigans going on in here, we can at least get a general idea of what's going on here. Okay, so let's start with this. All right, so let me get rid of this lovely scribble picture here because we don't need it. All right, so let's suppose that I have, oh gosh, I don't know. Let's do, I have a leading coefficient that's going to be greater than 0. Okay, so I'm going to have, in other words, I'm saying this, I have a positive leading term. Okay, and let's say I also know that my n is odd. So I have an odd degree polynomial. Okay, so if that's the case, if you think about your parent functions, if we're odd and we're positive, okay, we're going to have some sort of a graph that goes like this. Okay, and whatever else is going on in the polynomial, it's going to be like this every time. Okay, so what do we know? Well, if you think of this as negative infinity and positive infinity, we can talk about what the graph is doing as your x's go to negative infinity. Okay, so in other words, as I'm going out this direction, what is the graph doing? Okay, so we're going to say, what is the limit, or where is the graph going? Well, it's going down this way. So we're going to say, hey, that's going towards negative infinity. Okay. Then on the other hand, the limit as x goes towards positive infinity of my graph, okay, and I'm assuming this is my graph, f of x. All right, so this time, as I'm heading out to the right, out to Buzz Lightyear's house, infinity and beyond, all right, what's your graph doing? Okay, what's your graph doing? Well, it's taking off and going up high. It's going off to infinity also, okay? So these sorts of statements here, we're describing the end behavior of our graph. Okay, so that's what's happening there. All right, so let's try this again. Let's suppose this time I have an a sub n, an a sub n, which is less than 0. And let's stay odd. Okay, let's say n is still odd degree. All right, so this time we have a negative leading term. Okay, and our degree is odd. Well, let's see. What might that look like? Well, if we're going to turn that around, okay, so I'm negative odd. Maybe something like that could be our f of x. Okay, negative odd. All right, so what's going on the two ends? Okay, let's take a look at that leading term again so we can see in general what happens. So we're negative infinity to positive infinity. So the limit as x goes to negative infinity. All right, so what's happening to the left for your graph? Well, you're going off towards infinity. You're going up here, high. Okay. The other statement, as you go to the right forever on your graph. All right, what's happening as we go this direction? Well, your graph's heading down, so we're going to say it's headed to negative infinity. Okay. okay? All right, so there's our two situations for n is odd. All right, well, n, or your degree, is not always going to be odd. All right, so let's go again. So let's suppose for the next example, we start with leading term positive. Okay, so leading term is positive, so greater than 0. But this time, let's make our n be even, like x squared, x to the 4th, any of those sort of things. Okay, so maybe our graph looks like, I don't know, I'm just making up a little something here. Big old W for winner, winner, winner. Okay, so what's that going to do? Well, let's look at that in behavior. So we'll start again. The limit as x goes to negative infinity. So as your x's are going, again, whoops there, sorry. I love these color things. All right, so as we're going out this way towards negative infinity, small, 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 what in the world is happening to our graph? Well, this time we're going up, so that's going to go to positive infinity, okay? All right, so then if we go this side, the limit as x goes to positive infinity of our graph, okay, so this time we're going out to the right. Right. Big, 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 big. So what's going to happen to that graph? It keeps on going. So we're going to say it's going to positive infinity, okay? And if you notice on this one, with the even positive, we are double up. The two ends are up, and there's a little something, 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 something going on in between. So we're double up, infinity, infinity on the end behavior, okay? All right, one last case, and I bet you can guess. Let's put that leading term to be negative, okay? So leading term is negative, okay? And let's keep n even. All right, so if n is even as positive, you're double up. Well, if n is even and we're negative, we're going to be double down, however this goes. M for monarchs. How about that? Okay, so this time talking about the end behavior as x goes to negative infinity. Okay, so again, here we go. Changing the pen color. Going out here, negative infinity. So we go to negative infinity. This graph is also going to, you're right, negative infinity. Oh, let's see here. Negative infinity. And then on the other side, the limit as x goes to positive infinity, so we're going this way, okay, of our function is heading down this way. So you got it. It's also negative infinity. Okay, so then you notice that when you have even degree, okay, our limit statements are going to be the same. Either you're going up, up, so like here and here, up, up, or down, down, like over here. If I scroll back up here to talk about the odds, okay, if our degree that's right, degrees are odd, then you notice the limit statements are going to be opposite with one another. One's up, one's down. Whoops, I marked in the wrong place. Sorry about that. Let me get that out of here. Too many pens, okay? So if we're odd, we're going opposite directions on our limit statements or on the end behavior, okay? All right, I think I've got that all covered for you, and I hope that made some sense. And again, this is called the leading term test, talking about the end behavior of your polynomial. Have a great day, everyone.